Okay, lesson 25 is about monomial factoring, first of all. So a monomial, remember, is a polynomial with only one term. Mono is a Greek root meaning alone. A factor is one of two or more expressions that are multiplied. It's very important. That's what a factor is. Factoring is breaking a polynomial up into factors, that is, expressions that are multiplied, not added, not subtracted, multiplied. Monomial factoring is when we look at the terms of a polynomial and find their greatest common factor. Okay, so we're looking at this binomial right here, and we want to figure out what is the greatest common factor, the greatest factor that both of these terms share. We call these terms, remember, because they're separated by addition or subtraction. So this is a binomial because it has two terms. And we're looking at each term and we're thinking about what the factors are in those terms. And we want to find the greatest common factor, the greatest factor that will divide evenly into both of them. So we can see that they both have a 4. They do not both have an A, so not an A. And they both have one factor of X. This one has two factors of X, but they both have one. So the only thing we can factor out here is the 4 and the X. So now we're going to figure out what we have left. We are going to have two terms here. There have to be the same number as we started with. So there should be a plus sign between the two terms. So remember, this first term is made up of 4 factors, 4ax, x, 4ax squared. We took out 4 and the x, so we're left with ax. This second term is made up of 3 factors, 4x and y. We took out the 4x, so we're left with y. So that's it. We have factored this binomial. Okay, let's look at this next example. We want to factor this binomial. There are 2 terms, so we're going to look at the terms and see what the factors are. The first binomial has a factor of 4. The second one does not have a factor of 4, but they do both have a factor of 2 because 4 is 2 times 2 and 6 is 2 times 3. So we can factor out a 2. All right, if we look at the x part of these 2 terms, this first term has 2 factors of x, so xx. And the last one just has 1x, so we can only factor out 1 because they each have a factor of x. For the p's, we've got 2 of them here, p, p. Here we have 4 of them, p, 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 p. And so we can factor out 2 of them because they both have 2 of them. So p squared. And then for the k's, this one has 1, this one has 2, so they both have 1. And that's all we can factor out. So now we have to figure out what we have left. Remember, there are going to be 2 terms. Okay, so what's left when we factor out the 2x p squared k from the first term? Well, we're left with a factor of 2 from the 4. We're left with a factor of x to get x squared. And that's it. Everything else is right here in the monomial we factored out. The second term, what do we have left here? We factored out the 2, so we have a 3 left. X, we factored that out, so it's gone. The k, we have factored out 1 of them, so there's 1 left. And the p, we factored out 2 factors of p, so that means there'll be 2 left. So that is the factorization for that binomial. Okay, let's look at this one. This one is a trinomial. We're going to factor out the greatest common factor. So we'll look at all 3 terms. got 4x squared y, 2xy, and 10xy squared. If we look at the constants in each one, we've got 4, 2, and 10. The greatest common factor of those is 2. Then we've got x squared, x, and x. So they each have 1x, although the first one has 2, but we got to only choose what they all share. Common means they all share them. Y, y, and y squared. So there is a factor of y in each one. All right, so what do we have left for the first term? We have a 2 left because 2 times 2 is 4. We have an x left. And then moving on to the second term, minus 2xy. We don't have anything left but a factor of 1. And we have to put that there because when we multiply this out, this factorization we're doing, it should equal what we started with, or we're wrong. So we've got to have that 1 there. And then plus 10xy squared. So we have left over here. We factored out a 2, so we've got a 5 left. We factored out the x, so it's gone. We factored out one of these y factors, so we have 1 left. So this is the factorization for this trinomial. And make sure when you factor out the greatest common factor that you still have 3 terms inside the parentheses, or it's not going to equal what you started with. There will always be the same number of terms inside the parentheses as there were to start with. Okay, we've talked about this before. Multiplication and division are inverse operations. That means that one undoes the other. All right, and what I mean by that is if you take a number like 3 and you multiply it by 7, and then you divide it by 7, it's just like you didn't do anything because it's the same as it ever was. All right, and that is where cancellation comes from in fractions. We can use that fact that multiplication undoes division and vice versa to cancel factors in a fraction. The only time we can use cancellation is when the numerator and denominator have a common factor. All right, so if you have something like 2xy over x, the numerator has a factor of x, the denominator has a factor of x. So you're multiplying by x on top and then you're dividing by x. That fraction line means division. So I can cancel out the x's and I just end up with 2y. We cannot cancel terms in a sum where you're adding or subtracting. Only factors may be canceled. So if you have 2x plus y over x, you cannot cancel the x. Even though the x is multiplied by the 2, it's not multiplied by the y. It has to be a factor of the whole numerator before you can cancel it with this x that is a factor of the denominator. So you cannot cancel the x's here. No, no, no. All right, let's look at these 2 examples and see what we can cancel. All right, so we have 6x cubed plus x squared over x squared. Now, if you feel like you want to cancel the x squared here and the x squared here, that is wrong. The x squared up here is added to this other term. So you can't just cancel those x squareds and get 6x cubed. That will not work. It is not true because look, if I have 2 plus 4 divided by 4 and I cancel the 4's and say that equals 2, well, it doesn't equal 2. It's 6 over 4. That does not equal 2. So no, that is not going to happen. Okay, but we can see that every term in the numerator actually has a factor of x squared. So if we factor the numerator, we will be able to cancel. So the numerator, if you look at the 2 terms, you've got 6x cubed plus x squared. Both of those terms have an x squared factor. So I'm going to rewrite the fraction. The numerator, I'm going to factor out that x squared. So x squared times 6x is what we're left with, plus 1. Now we can cancel the x squared term and end up with 6x plus 1. But the thing we cancel has to be a factor. It has to be something that could be factored out of the numerator and the denominator. All right, if we look over here on part B, we can see that, again, you might want to cancel those x squareds, but you can't because it's addition. X squared is not a factor of the numerator. It's only something that's added to another term in the numerator. And there's not even a factor, there's no common factors between those two terms in the numerator. Anyway, there's nothing you could factor out. So this fraction is as reduced as it can possibly be. There's no way to reduce it any further. All right, lesson 26, trinomial factoring. So math is about finding patterns, and so we're going to use that fact to figure out how we can factor a trinomial. When we factor, we undo multiplication. It's like we're taking something that's been multiplied and we're dividing it up into its factors. I mean, we're factoring. Yes, that's what we're doing. In order to factor a trinomial, that means a polynomial with 3 terms, into 2 binomials, we need to see the pattern that happens when 2 binomials are multiplied. So here are 2 binomials, x plus 2 times x minus 5. Let's see what happens when we multiply them. So x times x is x squared. X times 5, negative 5, minus 5x. 2 times x is 2x, so plus 2x. And then 2 times negative 5 is negative 10, so minus 10. And if we add our like terms here, we have x squared minus 3x minus 10. All right, so let's just do these other ones and see if we see a pattern happening. So b plus 4 times b minus 1. B times b is b squared. B times negative 1 is minus b. 4 times b is plus 4b. And 4 times negative 1 is minus 4. And then if we add our like terms, we've got b squared plus 3b minus 4. If we look at this last one, x times x is x squared. X times negative 4 is minus 4x. Negative 3 times x is minus 3x. And negative 3 times negative 4 is plus 12. So that's x squared minus 7x plus 12. So let's see if we see a pattern with each term that we get here. All right, the first term in your trinomial is just the product of the first terms in the binomials, x times x. Your last term, the negative 10, is the product of the last terms of the binomial, the positive 2 and the negative 5. The 3x is the sum of the last 2 terms of the binomials, the 2 and the minus 5. So you add them. 2 minus 5 is negative 3. That's what it looks like. All right, next one, let's see if it's still true. B squared is the first times the first. Negative 4 is the last times the last. 4 times negative 1. The middle coefficient, 3, is 4 minus 1. So still working. The last one, x squared, is the first times the first. 12 is the last times the last. Negative 3 times negative 4 is 12. And then the middle coefficient, negative 7, is the sum of negative 3 and negative 4. So this pattern is going to work for us when we are factoring the kinds of trinomials in this lesson. Now, there are other trinomials that won't work this way exactly, but for these, this is how it's going to work. So the first term in the trinomial is the product of the first terms in the binomials. The last term in the trinomial is the product of the last terms in the binomials. The coefficient of the middle term in the trinomial is the sum of the last terms of the binomials. So we're going to use this fact to factor trinomials. We're going to have a trinomial now, so we're going to start with something like this, and we want to end up with something like this. We're going to unmultiply or factor. All right, so we've got x squared plus 6 minus 5x. First thing we need to do is get it in order because right now it's mixed up. We want the terms of x to go from the highest power to the lowest power to the constant. All right, so now we want to factor this. We know that the first two terms of the binomial should multiply together to give me the first term of the trinomial. So that's x times x gives me x squared. I know the last two terms of the binomials, I want them to multiply together to give me 6. Now, there are two possibilities for that because 3 times 2 is 6 and 6 times 1 is 6. Let's see what's going to work. We'll try 3 and 2. So 3 and 2. That does multiply together to give me 6. But these two numbers are supposed to add up to -5, the middle term coefficient. So they both would have to be negative for that to happen. So -3, -2. And this works because -3 times -2 is +6, which had to be true also. So this is the factorization for this trinomial. All right, this one we want to factor. And one of the things I didn't mention is that the first thing we have to do when we are factoring a trinomial is to factor out the greatest common factor. This group of numbers here, this trinomial, these terms, these three terms, don't have any common factors, but we can see that we have a negative sign in front of our x squared, and we don't want that. We'd rather have it positive. So what we're going to do is we're going to factor out a factor of -1. And we're going to see what we have left. If we do that, we'll have x squared minus 5x minus 14. Now, you cannot divide this expression by -1 and just make the negative sign go away. This is not an equation. An equation, you can multiply both sides of the equation by -1, and that's fine. But this isn't an equation. If you divide out a -1 here, you're going to change the value of this expression, and you can't do that. So you're going to factor out the -1 and not get rid of it. You're just going to leave it there. All right, so we've got the -1. Now we need to factor the trinomial. The first terms of the binomials should multiply together to give me the first term of the trinomial. That's going to be x times x. The last term of the trinomial, the two last terms of the binomials should multiply together to give me -14. There are a couple of ways to make -14. You could do 14 times 1, so make -14 times 1. You could do 14 times -1. You could do -7 times 2, or you could do 2 times -7. So there are a couple ways you can do this. Now, I'm going to think about the fact that my middle coefficient is supposed to be -5. So whatever two numbers I choose to multiply together to give me 14 need to have a sum of -5. If I look at 14 and 1, that's not going to happen. So I'm going to use the 7 and the 2. So if I put the 7 here and the 2 here, the question is which one needs to be positive and which one needs to be negative to give me a -5 when I add them together. That would have to be -7 and +2. So this is the factorization of this trinomial, -1 times x minus 7 times x plus 2. Okay, here's another one. We want to factor this one. We need to put it in order first. -3x squared plus 6x plus 24. So the first thing I want to do is factor out the common factor, greatest common factor. I can see that each term has a factor of 3. I'm going to factor out the negative 3 because that way I won't have a negative sign on my first term. So if I factor out negative 3, I am left with x squared minus 2x, because that would give me a positive 6x, and then minus 8. Now I'm going to factor the trinomial. Don't lose your negative 3. It has to be there. All right, so I know my first two terms in these binomials should multiply together to give me x. So x and x. My last two terms are supposed to multiply to give me negative 8. Well, that could be negative 8 and 1. It could be 8 and negative 1. It could be negative 2 and 4, or it could be 2 and negative 4. Those are all the choices. So the middle term coefficient has to be negative 2. These guys are not going to add up to negative 2 no matter what I do with them. So the 4 and the 2 are what we need here. And we want those to add up to negative 2 right here. So I'm going to make the 4 negative and the 2 positive. Okay, here's another one. We want to rearrange it. So we're going from the highest power of x to the lowest power of x. Negative 2x to the fourth plus 12x cubed plus 32x squared. If we look through here, each term we can see has a factor of 2 and a factor of x squared. So we're going to factor out 2x squared, but we're going to factor out negative 2x squared so that our first term in the trinomial we have left will be positive. So if I factor out a negative 2x squared, I'm going to be left with x squared. My next term is going to, what am I left with? I factored out a negative 2 and an x squared, so I'm going to be left with a negative 6 and an x. Factor out that negative 2, so I'll be left with a negative 16 and no x's because I factored out 2 of them. All right, so this is what we're left with inside. So I'm going to rewrite it, negative 2x squared times x squared minus 6x minus 16. Okay, so I just need to factor the trinomial part. And so let's draw my two pairs of parentheses, and don't forget the negative 2x squared. I'm going to have x first in each one, multiplying together give me x squared. The last term is 16. 16 and 1 cannot add up to 6, no matter what you do. 4 and 4 can't add up to 6. 2 and 8 can add up to 6 if, and we want it to add up to negative 6. So we want to make the negative on the 8, and then the 2 will be positive because negative 8 plus 2 is negative 6. So minus 8 plus 2. Okay, on lesson 27, rational expressions. A ratio is something that can be written as a fraction. Therefore, an expression containing fractions is called a rational expression. To add the terms of a rational expression, we must find the least common multiple of the denominators. All right, so what we have to do is look at what factors we're dealing with in our denominators. So the first denominator has a factor of x. That's it. The second denominator has a factor of x plus a because x is not a factor, a is not a factor. So the whole denominator is the factor, x plus a. So my common denominator has to have both of those things in it. It has to have both factors. The least common denominator is going to be x times x plus a for both fractions. And we need to change the fractions so that they have this denominator. So the first fraction has an x, but it doesn't have the x plus a. So I'm going to have to multiply the top and the bottom of that fraction by x plus a to get this for the denominator. So if I multiply the numerator by x plus a, I will have 4 times x plus a. The second fraction, I have the x plus a factor already. I need an x, so I'm going to have to multiply the top and the bottom of this fraction by x. So the numerator will end up being 6x. And that is how you would add those two rational expressions. If we look at the three terms in this expression that has rational expressions in it, let's see what the factors of the denominators are. X plus 4 is a factor, not x, not 4, because they're not factors, they're being added, but the whole thing is a factor that we will need. The 6, the denominator is 1, so that's the only factor in that is 1. The last fraction, the last ratio, is x squared. So we're going to need a factor of x squared because we don't have one yet. So the least common denominator is got to have the x plus 4, and it has to have 1, which we don't need to write, and it has to have x squared. Okay, so the first fraction, we already have the x plus 4. So we just need to multiply the top and the bottom of this fraction by x squared in order to have the right denominator. The top, we will have x squared times x plus 2. The second fraction doesn't have either of the factors. It doesn't have x squared, it doesn't have x plus 4 in the denominator, so we're going to have to multiply the top and the bottom of that fraction by x plus 4 times x squared to get that denominator. So in the numerator, we'll have 6x squared times x plus 4. And then in the last, we have the x squared, but we don't have the x plus 4. So we'll have to multiply the top and the bottom by x plus 4. So the numerator will be 2 times x plus 4. So let's go ahead and multiply all this out. Now this one has more factors than we can see right now because this first one, the denominator, can be factored. So before we find the least common denominator, we're going to factor the first denominator. So x plus 2 over, we're going to factor that into two binomials. So we know the first two, the last two terms have to be 3 and 1, and then they have to add up to positive 4, so that's plus 3 and plus 1. So now our second fraction here is x times x plus 1. So there are three factors involved in the denominators: x plus 3, x plus 1, and x. Okay? The first fraction here has the x plus 3, it has the x plus 1, but it doesn't have the x. So I've got to multiply the top and the bottom of this fraction by x to get what I'm looking for. So the numerator for that will end up being x times x plus 2. The second fraction has the x, it has the x plus 1, but it doesn't have the x plus 3. All right, now I'm going to go ahead and multiply it out and do the subtraction. So the first fraction has x squared plus 2x, and then minus x minus 3. If you have a minus sign in front of the fraction, you have to distribute it to all the terms in the numerator. And then the denominator is x times x plus 1 times x plus 3. And if I add my like terms in the numerator, I'm going to have x squared plus x minus 3. And if I multiply that denominator out, I'm going to have x cubed plus 4x squared plus 3x